You know, when we think about clean energy, our minds usually jump straight to the big stuff, right? Those massive wind turbines spinning on a hillside, or huge fields of solar panels soaking up the sun. But what if I told you the real revolution, the thing that's making all of this actually work, is completely invisible? In this explainer, we're going to look past the hardware and dive into the hidden engine of data, code, and AI that's really powering this green transition.
I mean, the steel and silicone are impressive, don't get me wrong, but think about it. How do you manage the pure chaos of nature, the sun that hides behind clouds, the wind that dies down, and turn that into reliable power for millions of people? Well, the answer isn't just about building better hardware anymore. It's about having better data.
We're really entering a brand new phase in the renewable energy story. See, the challenge isn't just about building more turbines or slapping more panels on roofs. The next frontier, where the real action is all about making the entire system incredibly smart, efficient, and predictive. And that is the invisible revolution.
And this is the key takeaway, right here. We're shifting from a hardware problem to a software and intelligence problem. The biggest leaps forward in clean energy are no longer just coming from better materials. They're coming from smarter algorithms that can predict, optimize, and manage every single watt of power flowing through the system.
So the first big hurdle with renewables has always been nature's unpredictability. The sun doesn't always shine, the wind doesn't always blow. For decades, this was the biggest argument against them. But now we're finally starting to tame that chaos, and we're doing it with code.
And that brings us to this really cool concept, forecastability. It's a new way of thinking. Instead of just measuring how much the sun's output changes, researchers are now measuring how predictable that change is. It's a subtle shift, but it's incredibly powerful. It lets us find patterns, find certainty in a system that once just looked totally chaotic.
And this really shows you the difference. The old way was, let's be honest, kind of like a guessing game. You'd look at a broad weather forecast and hope for the best. But the new way? It's surgical. It uses advanced AI, these things called temporal fusion transformers, that are built to understand complex patterns over time to just chew through mountains of data. They find these hidden connections and predict energy output with a precision that was unthinkable just a few years ago.
And the impact? It's massive. Using these new AI models, researchers have slashed forecasting errors for wind power by up to 60%. I mean, think about that. That's the difference between a grid operator guessing what's going to happen and knowing what's going to happen. And that knowledge is what prevents blackouts and keeps our lights on.
And it's not just about predicting if it's going to be sunny or windy. These models are tackling these incredibly complex, weird variables. They can now model how a dust plume from the Sahara Desert is going to affect solar production all the way across Europe. They can predict how much energy a solar farm will lose just from a thin layer of dirt, something called soiling, which can cut output by over 30%. They're even using neural networks to figure out wind speed miles offshore just by looking at ocean radar data. It's wild.
Okay, so we've started to tame the chaos with prediction. What's the next step? Optimization. Now that we can forecast supply, how do we squeeze every last possible watt of energy from the resources we already have? Well, this is where machine learning comes in, fine-tuning every single component for maximum efficiency.
Data also helps us make much smarter choices about the technologies we already use. Take biomass. You can just burn it for energy, sure, or you can use a more advanced process called pyrolysis. And as the data here clearly shows, pyrolysis has a way better greenhouse gas performance. That's the kind of decision you can only make with confidence when you've got the models to back it up.
Here's another perfect example. The old system for classifying climates to predict how well a solar panel would work was pretty blunt. A new machine learning method just cut the error rate by 58%. That means we can put solar systems in the exact right locations for their specific design, which dramatically boost how well they perform over their lifetime.
And the applications are just popping up everywhere. Machine learning is being used to predict the exact chemical makeup of biochar to make it a better fertilizer. It's optimizing the efficiency of pumps that are running in reverse to act as turbines. It's fine-tuning microbial fuel cells, and even designing smarter solar trackers specifically to produce more green hydrogen. The sheer breadth of this optimization is just staggering.
All right, so we can predict supply and we can optimize all the individual components. The next logical step, of course, is to scale up. We're now using all this data to design and operate entire energy ecosystems, from smart local grids all the way up to entire renewable energy communities.
Even the planning process itself is completely data-driven now.
Planners can use geographic data to map a whole city, model the energy demand of every single building, and then simulate different community layouts. Then they can run optimizations to find the absolute perfect mix of solar panels and batteries to make that community as self-sufficient and cost-effective as possible.
A huge part of this is understanding the resources that are basically hidden in plain sight. This table compares two of them, the batteries in our electric cars and our electric hot water heaters. City-scale models can analyze all the trade-offs. You see, EVs have a ton of storage capacity, but they're only useful to the grid when they're plugged in. Hot water tanks, they have less capacity, but they're always connected. A smart grid can learn to leverage both perfectly.
Bottom line, software is just fundamentally changing how our grids work. We're starting to see things like adaptive peer-to-peer pricing, where you can sell the excess solar power from your roof directly to your neighbor. We're using complex programming to design off-grid systems that can handle totally unpredictable weather. Our grids are almost becoming, well, living, thinking organisms.
But all this incredible technology, the prediction, the optimization, the smart grids, it all leads to one final, and I think most essential question. As we build this incredible clean energy future, what's the impact on people? How do we make sure this transition isn't just efficient, but that it's also fair?
Well, let's start with some good news. A big study in Canada found something amazing. On average, when a renewable energy project was built in the community, local education scores went up by 6.11 percentage points. That's a huge co-benefit, and it suggests these projects can bring real, tangible improvements to people's lives.
But here's the crucial catch. That very same study found that Indigenous communities saw way smaller gains, sometimes more than 12 points lower. In fact, some models even estimated a net negative effect on education scores. And that is a stark warning that if we aren't intentional about this, the benefits of the clean energy transition will not be shared equally.
But on the other hand, when we deployed this technology with equity as a goal from the very beginning, it can be a powerful force for good. For example, research from a project in Belfast showed that by strategically targeting solar installations in homes that were struggling with fuel poverty, they could directly tackle energy costs, lower the barriers for people to get involved, and empower the whole community.
So there's no question that this invisible engine of data and AI is speeding up the clean energy transition. It's making our systems smarter, more efficient, more resilient. But the ultimate algorithm, the one we really need to solve, is the human one. As our technology gets more and more intelligent, the real challenge for us is to become wiser, to make sure that this incredible power we're building creates a future that isn't just clean, but is truly equitable for everyone.